In this lesson, we're going to talk about different yields. So up until now, we have been calculating based on a certain amount of reactant, how much product would be produced. And that is our theoretical yield. So in theory, as we do some calculations, what would we expect to end up with? An experimental yield is going to be how much is actually produced when the chemical reaction is actually carried out. And then percentage yield is the ratio of the actual or experimental yield to the theoretical yield as a percent. It measures how efficient the reaction is. So if we have a high percentage, then we are getting very close to what in theory we would expect to get. And so that is a very efficient process. And if we have a low percent yield, that means that we're not getting near as much product as we expect based on the amount of reactants that are available. And so that would not be an efficient process. So the percent yield is equal to the experimental or actual yield. So this is what is measured when the chemical reaction is actually carried out, over the theoretical yield, which is based on the amount that we calculate to end up getting, and then multiply by 100 to convert the decimal to a percent. So what are some reasons why we wouldn't have a 100% yield? So if we have impure reactants, that means that we have some additional compounds or elements that are a part of our reactants, which means that there may be other side reactions going on. So that means some of our reactants are going to be creating different products than what is actually in our chemical equation that we write. So we'll have some unwanted products, and that means that not everything is becoming the products that we have written in the chemical equation. The actual yield can be lower than theoretical if some product is lost. So depending on what form or what state our product is in and mixed in with multiple products as we are trying to separate them out. So if we need to do some filtering or transferring between containers, anything that's a gas, if we don't have things fully sealed, then we can be losing some of that product to our surroundings. And then if we have a precipitate forming, so remember that is a solid that forms when we have two liquids or two aqueous solutions that react together. And so that precipitate, that solid product, is going to fall or precipitate to the bottom. And so that, because of the liquid around it, and unless it is fully dried, it may actually give us more than 100% yield, because we would not only be weighing that product, but also water or some other liquid that is in there. So we would have to make sure for a precipitate that we have complete drying happening before measuring the mass of that product. So an example, calcium carbonate is synthesized by heating, as shown in the following equation. So calcium oxide reacts with carbon dioxide in a 1-to-1 ratio to produce calcium carbonate. So what's the theoretical yield of calcium carbonate if 24.8 grams of calcium oxide is heated with 43 grams of carbon dioxide? And what's the percent yield if 33.1 grams of calcium carbonate is produced? So for question 1, what's the theoretical yield of calcium carbonate? So I'm given the masses of two different reactants. So we saw in our limiting and excess reagents lesson that we need to figure out if these are the exact amounts we need in our 1-to-1 mole ratio, or if one of these is going to be limiting how much product we can make. So we need to figure out which is our limiting reagent, and then calculate the theoretical yield based off of that. So up until now, all of the stoic calculations we have been doing have all been calculating theoretical yields for our products. So in theory, when we calculate based on our knowledge of the balanced equation and the multimole ratios from there and the masses that we have to start with, what would we expect to happen? So those have all been theoretical yields. And then this is given as an actual yield. So if this reaction is actually carried out with these amounts of reactants And this is the amount of calcium carbonate. So once we calculate the theoretical yield from A, we can use that with our actual or experimental yield here to calculate the percent yield. Okay, so first thing we're going to do, we're just going to pick one. So I'm going to go with the first one, 24.8 grams of calcium oxide. So I'm going to use the molar mass to convert to moles. So 56.08 grams of calcium oxide per mole of calcium oxide. So that's going to cancel my mass of calcium oxide, convert it to moles. Using my mole to mole ratio, so 1 mole of calcium oxide for 1 mole of carbon dioxide. So that is going to tell me how many moles of carbon dioxide I would need for this amount of calcium oxide. And my molar mass there for 1 mole of carbon dioxide, its mass is 44.01 grams. So this is going to calculate for me how many grams of of carbon dioxide are needed to react with 24.8 grams of calcium oxide. And that is 19.5 grams. I have 43 grams of carbon dioxide, so I have more than enough carbon dioxide to fully react the calcium oxide. So that means that calcium oxide is my limiting reagent or limiting reactant. Carbon dioxide is in excess. Now here we're not asked how much we are in excess, so we don't need to do the 43 subtract 19.5. The important part here is to calculate in theory how much calcium carbonate will be created. We need to use the 24.8 grams of calcium oxide. So that's our starting point here then, is the 24.8 grams of calcium oxide. So the first part is all the same, 56.08 grams per mole for calcium oxide. Now mole to mole ratio from calcium oxide to calcium carbonate, so still 1:1. And now I need my molar mass for calcium carbonate. So 1 calcium atom at 40.08, if I remember correctly, 1 carbon at 12.01, and 3 oxygen each at 16. So that is going to give me per mole of calcium carbonate 100.09 grams. So these all cancel so that my final answer here is in grams of calcium carbonate. So 44.3 grams is the theoretical yield of calcium carbonate. So that's how much I would expect to be produced if 24.8 grams of calcium oxide fully reacted with the carbon dioxide. So I have 43 grams available. I only need to use 19.5 grams to react with the 24.8 grams of calcium oxide. So this is what I would expect, but only 33.1 grams are produced. So percentage yield is the actual or experimental, so that's the 33.1 grams, and the the theoretical amount that we calculated was 44.3. So once we multiply that by 100, our percentage yield is 74.7% for this. So not a fantastic yield, but not terrible, although often in industry, the percentage yields are not always incredibly high.